Today we're going to talk about the properties of square roots. We've already talked about a couple of these properties and we just want to kind of go a little bit further with them. It's important properties to be able to deal with, so let's just take a look. The product property. So in algebra terms, we kind of already talked about this one in the pre-6 video, but when you have something that is being the square root of x times y, we could rewrite that as two separate square root of x times the square root of y. Both x and y have to be greater than or equal to 0. Again, if they were negatives, we wouldn't be able to do it. We wouldn't have any real number solutions. So as we kind of also said, is if I was dealing with something that was the square root of 45. Well, again, we want to try to break these down as much as we can. So I can look at this as the square root of 9 times 5, which is the square root of 9 times the square root of 5, remembering that the square root of 9 is a nice perfect square, meaning it's going to give us an integer answer, actually a whole number answer. The square root of 9 is 3, and the square root of 5, I can't do anything further, so 3 times the square root of 5 is how we reduce the square root of 45. The second one is the quotient property. Again, in algebra terms, we talked about how when we have a fraction that looks like x divided by y and we're taking the square root, we can look at each of the numerator as a square root of x and the denominator as a square root of y, where x has to be greater than or equal to 0 and y has to be greater than 0. Okay, so y has to be greater than 0. Not only can it not be a negative number, but it also can't be 0 because then I'm dividing by 0. So the example we looked at in pre-6 was if I had the square root of 3/4, I can consider this the square root of 3 over the square root of 4. Square root of 4 is a perfect square, so at least we can reduce it a little bit to get square root of 3 over 2. So, one of the things that we are doing is that we want to use our factors that are perfect squares. So, perfect squares. That is really what you want to focus on to try to reduce these as far as we can. So we want to break these down as far as we can, and we want to keep looking for perfect squares. And again, there's not one answered way to get to these. I could find all kinds of different factor pairs, but I want to find factor pairs that are going to start giving me perfect squares. So 150. I could certainly do 10 times 15, but I don't know how that's going to help me immediately. I want to search for some other numbers. 25 times 6 is also 150. That's going to be better because 25 is a perfect square. 25, once I take that, is going to give me 5 square roots of 6. I can't go any further, so 5 square roots of 6 is my answer. On the second one, I would take the square root of 15 over the square root of 64, and that's just going to be the square root of 15 over 8. So what we want to remember here is a square root is simplified when the radicand has no perfect squares except 1. Obviously 1 is a perfect square, and it will be in all of our numbers as a factor, but it wouldn't obviously help us bring it down any further. So when we see that the radicand has no more perfect squares in it, then we can say that we are simplified. So next, what we want to look at here is evaluating square roots. So here we have a radical sign with an expression in the radicand that we're going to see a little bit later on that's going to be really kind of important when we talk about our quadratics. So what we're going to do is we're basically just going to use our plug in and solve. And we just have to make sure that we're careful on how we plug in and solve. So there's the radical sign. B is a -8. So I plug it in. 4 is always going to be there. The A value is a 2. C value is a 4. And again, we're looking at just solving this expression, so it's all regular numbers, so it is PEMDAS. The radical sign is going to be the last thing. We've got to take care of the radicand first. So when -8 squared, I get 64. Subtract, I get 4 times 2 is 8 times 4 is 32. That's going to give us the square root of 32. Now we want to reduce this a little bit, see what we can simplify this to. And I look at 32 and I can see a perfect square of 16 times the square root of 2. Square root of 16 is 4. Square root of 2, there is nothing further I can do in the square root of 2, so 4 square roots of 2. On the second one, again, we're going to talk about how we get this big radical sign. We're going to plug in our values, so -6 is our B value, minus 4, A value is a 2, the C value is a -5. So when I go through and follow through my order of operations, I'm going to get 36. On the other side, I'm going to get 4 times 2 is 8, times 5 is 40. And it's a negative, so we get a plus 40. That becomes a square root of 76. Now this one's kind of a tricky one. It's kind of hard to find the pairs that you're looking for. You could certainly start with 2's, but I also see 4's because I know 4 times 20 is 80. So if 4 times 20 is 80, 4 times 19 is 76. I know 4 is a perfect square, so 2 times the square root of 19 would be simple form. Now we get into some of the trickier ones. Sometimes this is where we run into some problems because people try to push things together wherever we can't push things together. So we want to simplify this 6 plus square root of 8 all over 2. So we've got to remember, how does that work? Well, remember, when I have two terms here separated by a plus or a minus, this 2 has got to go into both of the terms. It can't just go into one. It can't just go into the other one. So I need to make sure that I'm doing both things. I could certainly take and separate those two, as long as I make sure that they both have the 2 under it. I can certainly do that. There's nothing wrong with that. It makes it a little bit more work in the long run, but if it's something that would be helpful to you, you can do that. At this point, I'm just going to kind of go with it with the idea that we're not going to separate it. So what I first want to do is look at my numerator. And I want to think about this number right here, the square root of 8. And can I simplify that a little bit? Well, if I think of the square root of 8, I'm going to leave these numbers like that. The square root of 8 is also the way of writing square root of 4 times the square root of 2. And again, I'm looking for those perfect squares. So once I have that, I can then change this now to 6. The square root of 4 is 2. Square roots of 2 all over 2. At this point, I do want to kind of simplify a little bit further. So what I want to think about here is I want to look at this 6 divided by 2. That's going to give me 3. Then I also, at the same time, that 2, because we're adding the plus 2 times the square root of 2, the 2's are going to cancel out, and give me the square root of 2. But notice how they both have to get divided by that 2. So my answer becomes 3 plus the square root of 2. So again, if you want to separate them like I did up at the top, you can certainly do that. Just doing that over here is certainly fine. You would have gotten 6 divided by 2 equals the 3. The square root of 8 becomes the square root of 4 times the square root of 2, and then the 2's would cancel here and would still leave you with the same answer. I think in some ways I would like you to try not to do that, but if it is something that would help you for a little while, that is certainly fine. On the next one. So with that in mind, I'm going to leave it just the way it is, and I'm going to kind of deal with what the numerator looks like first. So negative 1 is going to stay the same. The negative square root of 27 can also be written as the negative square root of 9 times the square root of 3. Again, I'm looking for the perfect squares. That is going to turn into negative 1 minus 3 square roots of 3 over 4. And this is a situation where there's really not much else I can do here. Some people might say they'd like to see the negative 1/4 minus 3/4, 3 square roots of 3 over 4. I personally think it's just as well this far down. There's nothing I can really do to make it any more simple than this, so that is really all I have to do in this situation. But it's definitely important that I get the 3 square roots of 3 from the square root of 27. So a little more practice over here. Again, this is your quotient property. So if I see the square root of 23 ninths, I can say that's the same thing as the square root of 23 over the square root of 9. And at least, because we have a perfect square in my denominator, I can at least do that piece to get square root of 23 over 3. And for the second one, I'm trying to simplify the negative square root of 80. So what we want to think about is, what can I change that into? Well, I could certainly do 10 times 8, but I also can think of 16 times 5. And again, sometimes you're going to say, well, how did you know that? You just know that because you know the answers in the book. It's important that you just keep trying different number sense. Eventually you'll start seeing some of the perfect squares in our numbers. But if I can see the 16 right away, I can then make this negative 4 square roots of 5 a little bit easier. So let me just go through one as if I didn't already have that. So let's go back. I said square root of 8 times the square root of 10. So neither of those are perfect squares. But then remember, I can break down the square root of 8. Now I can see a 4 and a 2. Square root of 10 is the square root of 2 and the square root of 5. Well, square root of 4 is 2. The square root of 2 times the square root of 2 becomes the square root of 4, and the square root of 4 is 2. And the square root of 5 really has nothing to go with it. And then when I combine, that's another way that I can see that answer. And again, just notice there's not only one way to get there. Depends on which way you see it. You can save yourself some time if you can find your higher perfect squares first. But if you don't see it, just keep going with factors that get to the next numbers. On our practice number 3, here we have a formula that we're going to be plugging in and trying to figure it all out and see what these numbers look like. Looks kind of complicated. We're going to see how this goes. So the very first thing we're going to do is C. We don't have anything that goes with C. We're going to come to the other side, and I started to do that when I shouldn't have yet. We're going to come to the other side, and we have 2 pi. We're going to leave pi just the way it is for now. We have a squared plus b squared. A is 14 squared. B is 6 squared, and it's divided by 2. So C, again, we'll keep the 2 pi. We've got a little bit of work to do on the inside. 14 squared is 196 plus 36 divided by 2. 2 pi, we get 232 divided by 2. And we're kind of getting there. I'm going to get 116. Now from this point we want to kind of simplify a little bit further. When I start thinking about numbers that go into 1/16, again, I think about a number like the number 4. 4 will go into 120 30 times. So I know that 4 is going to go in, so I might as well kind of use that. And there might be another higher one in there, but it's going to be 4 times 29. 4 times 30 is 120. 4 times 29 is the 1/16. So that's going to give us 2 times pi times 2 times the square root of 29. And when I simplify this, we need a little more space here. When I simplify this a little bit further, now I'm going to get 4 pi square root of 29. That's when I'm really going to use my calculator. And I'm going to do either the pi button, or I could do 3.14. And when I multiply all of this out, it's approximately 68 feet. Okay? And on our last one here. So again, we're going to do, with the terms being connected with the pluses or the minuses, we need to make sure that the number in the denominator goes into both terms. So first what I want to focus on is, how do I break down the square root of 80? Well, again, if I focus on 4 and 20, could do 4 and 20. I could focus on 8 and 10. We already did 16 and 5 and it worked out nicely. So let's just focus on that. I can combine the bottom to get 6. So I would have 4 square roots of 5 over 6. And now again, both of these terms have to get the 6. Well, if I think about 2/6 here, we know that that is 1/3. If I focus then on the 4/6, I know that is 2/3, and the square root of 5 is in my numerator still. And because these thirds are there, we might as well put them all together. So 1 minus 2 square roots of 5. And that would be our simplified answer. Now, if you have any questions, feel free to ask me in class. Again, this is an important section to make sure we can put together these square roots and simplify them, not just run them through calculators. We want to be able to simplify them with our perfect squares.